Alright, what's going on, guys? So last video I mentioned some of these sensors that I will be covering today, their differences, kind of pros and cons, cost comparison, technical comparison, and which one would be ideal for our projects, which is drones. So starting with ultrasonic sensors, by definition it measures a target, measures distance of target by emitting ultrasonic sound wave and converting the reflected sound into electric signal. Basically, since it's a sound wave, it measures how long it takes from, I'm going to zoom in on this picture, basically how long it takes from the sound to move from the emitter back to the detector. So the emitter emits sound waves, hits the object, and reflects back to the detector, and the amount of time that it takes. Given that the speed of sound doesn't change, it can calculate what is the distance, and obviously it has to be connected to a microcontroller. Now, some of the cons: it might have fluctuations when propellers turn at high speeds. This might not always be the case, but I have talked to some of my friends that it happens when they have it on the drone. The propeller starts turning at high speeds, and it might affect it slightly, even though the ultrasonic sensor is not moving. The reading might be different, because of the high speeds of propellers. Now, second one is that by temperature increase, we have the sound waves traveling faster, and it might show the distance closer than it actually is. So high temperatures, it might have inaccurate readings. And last one, in smoky environments, it doesn't work as well either. Now, some of the pros is that it's easy to use, it's relatively cheap, but I will compare the cost of ultrasonic sensors with infrared sensors in a bit. It's not cheaper, however it's cheaper than a lot of other sensors. It can cover distance, obviously, so it is made for measuring distances, and the weight is relatively light, which is important for our applications. What we want to have components as light as possible with efficiency as high as possible to operate the drone properly. And the last one is that it's not affected by brightness, and I will mention that why brightness is important for us. Alright, so we covered ultrasonic sensors. Now moving on to infrared. By definition, it detects heat or motion of objects by emitting or detecting infrared radiation. There are two types of infrared sensors, the first one being active and the second one being the passive, or the short version is AIR, and PIR is not really commonly used, but regardless, it's good to know. The active infrared sensor, it actively sends energy. The passive, it basically is a read-only device, kind of like a read-only device. So for active, we have motion plus identification measurements, but for passive, it's only motion measurements. Other examples of active sensors are ultrasonic or microwave. There are more examples, but just thought it's good to bring it up here since we are covering sensors. Now, for passive infrared sensors, it is great for detecting general movement. They do not give more information about the object. However, an example of that is the automatic doors that are installed in malls and different areas. When a person enters, it detects the object in between transmitter and emitter. For active infrared sensors, we have a process. Basically, it emits, the emitter sends out a beam of light. If no object is there, the receiver will obviously not see, will detect the light, the signal that was originally emitted by the emitter. I don't know if I said that right. But if there is an object, it will not receive that signal back from the emitter, and therefore it concludes that there is an object, simply put. So I have this picture here. So you can see the object in the middle starts by emitting, and if the object's there, it reflects back, it fails to reflect back the signal that was originally sent, so it concludes the object is there. It's a very simple process. Now, some of the cons of infrared sensors is that they're affected by sunlight. They will still work if you want to use them outside, but it's not ideal. The readings will be inaccurate, and they're less reliable compared to ultrasonic sensors. However, the pros are they are cheaper compared to ultrasonic. So, if you have to do like a decision matrix analysis for your project, for our case drones, that we want to compromise cost or compromise reliability for cost. It's cheaper if you're not under cost constraint. It's definitely better to go with ultrasonic. And another pro for these sensors is that they're more accurate measurements for smaller ranges. Ultrasonic can also be used for small ranges, but since it's the timing has to be very accurate. Think about the speed of sound, right? That's how ultrasonic works. But for infrared, it would be, from my understanding, it would be more accurate for like smaller range measurements. Alright, now last one, LiDAR sensors. Definition is that remote sensing method that uses light in the form of pulsed laser to measure ranges, and it uses basically laser signals. Pulse laser basically is a laser that emits light in the form of light flashes rather than continuous mode. We will not get into it. It's a completely different topic. I might be covering it in the future videos, but it's irrelevant. Basically, LiDAR sensors they help create 3D models of objects being detected. So think about if you want to have like a sort of a map of an environment, this would be the best option to go with. It's not useful for our applications where we're working on creating simple small drones. It's usually for big drones. So cons, obviously they're very expensive. It's high tech, so it should be expensive. For the second con is that it's for larger drones or airplanes, as I mentioned earlier, and accurate for longer distances. So if you want to set it up for a small drone, it's not wise to do that. Second is that it wouldn't have accurate reading for like shorter ranges. And some of the pros obviously provide detailed models of objects, as I said, not dependent on light source, which is great if you compare it to infrared, where they are affected by direct sunlight, and they're automated system, so they're relatively independent from human interaction. And in this picture, you can see principles of LiDAR and LiDAR usage. It's not a detailed picture, but regardless, it's good to sort of see how it works. And for the next video, I will be covering ESP32 microcontroller.